So for example number 2, yeah, we'll do this. It's basically kind of the same thing. So now they give us the number. Now we're going to go the other way. So we have 2.33 times 10 to the negative 4. Okay. And so what does that equal? Well, I'm going to write my 2, 3, 3. So how many spaces am I going to move that decimal? Was it 6? Oh, 6. My bad. 6. So how many spaces are we going to move that decimal? Well, 6 spaces. But which direction? Think of a number line. The right is positive. We're moving it to the left. Remember, the negative power means it's going to be a decimal. If I move this direction, in other words, if I start here and I go 1, 2, 3, 4, 5, 6, I'm going to have a bunch of zeros here. That's a really big number and not a fraction, not less than 1. So if you have a power that's negative, it has to be less than 1. So if you can't remember left or right or how do I move it, you have to remember that a negative power of 10 has to be less than 1. But if I go 6 spaces this way, and I go 1, 2, 3, 4, 5, 6, and I put my decimal here, and then I put zeros for placeholders, 1, 2, 3, 4, 5. Now I have a number that's less than 1. And that makes sense, right? So negative power, let's write that down so we don't forget. Negative powers are less than 1. Okay? Positive powers tend to be greater than 1. Or, yeah. Let me think. Yeah. So if you have a positive power and you move the decimal, it should be greater than 1. Okay? And that is basically it. Now, let's talk about there's a question here, and for question number 7 out of your textbook, it says explain whether 0.9 times 10 to the, is that negative 5? Because my book is really tiny. Negative 5. I got the teacher's edition, and it's like it's half the page in the page. It's not that I can't see. Is written in scientific notation. If not, write the number correctly. Okay. So they're saying, is this written correctly? Well, first of all, is it? Yeah. So, not correct. So write that down there. Remember, you need a number in the front, 1 digit in the front, greater than 0, right? You can't have a 0. See how they have this 0 here? Now, mathematically, you could write it down this way, but that's technically not scientific notation. Okay, so you got to have a number in the front and then some other numbers, whatever they are, times 10 to some power. That's the right way to do it. So then you would say the correct way, draw a little arrow, would be, we need to move this decimal 1 space this way, right? 9.0. And then we got to think about how that looks. This is the weird thing. Is it negative 6 or is it negative 4 times 10 to the negative 6. And there's not really a good shortcut. If I say, remember, you move this way and you move that way, you guys will get the shortcuts confused. What I will say is you can always verify your answer. So let's pull out, oh, can I get 2 volunteers? Pass out you, and you have a question? Yes. So what we could do is we could verify this on the calculator and see if it's the same. In fact, I think when we enter this in the calculator, it should automatically pull up. While you guys are getting your calculators, I'm going to plug it in. So if I say 0.9 times 10 raised to the negative 5, it should convert it automatically to scientific notation, right? And remember that this this e to the negative 6 is the same. That's how the calculator programs itself to do scientific notation. So if I plug this in here, right? And I do want you, I know I ran through it kind of quick, but just do it real quick on the calculator and see. But these two things mean the same thing, right? This E on a calculator, E means 10 to the whatever. So if I say E to the question mark, then it's 10 to the question mark, okay? So this is like 10 raised to the negative 6, okay? There are some rules where I'll say if you move the decimal to the right, then you increase it. But see, you're moving. What happens is kids forget what they're moving, right? So if I'm converting a number to scientific notation, we move the decimal a certain number of spaces. But if I take scientific notation and convert it to the number, I move in the opposite direction. So if I say you move left this way, you increase by 1. If you move right, and you guys will get confused and do the wrong thing at the wrong time. That's why I like to verify with the calculator, because the calculator knows it. They just do it. That way you won't make a mistake. Eventually, you could think that in terms that way, like Mr. Adams does. But that just takes a lot of practice. So use the calculator for now. Just, until you get the hang of things. Let's do question number 8. And oh, you know what? I went ahead of myself. So we'll come back to number 8 in a second. Let's do 4, 5, and 6 real quick. So you guys do 4, 5, and 6. Which is actually on the previous page. That's where I got confused. I thought it was 9, 10, and 11. So actually, this is on page 46. I kind of skipped over it. All right, I'll race you guys. You ready? Let's see. So if I move this decimal 1, 2, 3, 4, 5, is that 8.29 times 10 to the negative 5? And then for this one, if I go 1, 2, 3, 4, 5, 6, 7, is that 3.02 times 10 to the negative 7? Okay. And then this one says a typical red blood cells in human blood has a diameter of approximately bunch of zeros and 7. So let's count. 1, 2, 3, 4, 5, 6. So it's 7.0 times 10 to the negative 6. Let me double check that one just to make sure. Yeah. Oh, meters, right? Because they say meters. No, you just say meters. All right. Any questions on that one?